When you start a screwdriver and stop it, you can see it kind of rocks around a little bit. But that's not a concern here because I've balanced this motor system. So basically the motor is spinning in one direction and the output shaft is spinning in the opposite direction, and I've counterbalanced it with some weights here such that when I start it and stop it, it doesn't produce any reaction force. This episode is brought to you by Squarespace. Normally, if you have a big beefy motor and you're spinning it up, you have to worry about it kind of wanting to hop out of your hands. The advantage of this is that basically I can completely counterbalance the rotating mass of the printer bed. And what that means is that I can drive it with high speeds and accelerations without it setting up some sort of resonance or shaking the printer apart. When you're dealing with really large printers, they tend to have lower resonant frequencies just because larger, heavier structures tend to wobble around a little bit more slowly. You can counteract that by adding a bunch of structural supports, adding like steel sheets and panels and trusses and stuff to stiffen the whole structure up. But that increases the overall mass of the printer. You end up with more mass, it's heavier to move around. You require more fasteners and material to build the whole thing. And it really detracts from a lot of the main advantages of having a 3D printer. 3D printers, they're light, they're easy to move around. I should also note I've added a 10-to-1 gear reduction on the top here so that I can get higher torques. On the large polar printer that I'm working on, it needs quite a bit of torque because that big plate is thick aluminum and it's pretty heavy. So the 10-to-1 gear reduction will help me get more precision and greater torque. And I chose a 10-to-1 gear reduction because I can get pretty good speed out of it. You can see if I had a big printer bed, this would be plenty of speed to be able to spin that thing back and forth as I'm printing. And the accelerations on this thing are pretty impressive as well. The motor that we're looking at today is provided by A3DP. They sent this over for me to check out. They told me not to call it a stepper motor. It looks like a stepper motor and acts like a stepper motor, so that's what I'm going to call it. In actuality, it's some sort of hybrid servo motor that acts like a stepper motor. Basically, you get all sorts of performance benefits, but it's still in the exact same form factor, and it receives the same signals that a stepper motor would receive. And the benefits of this motor is that it's faster, stronger, more precise, and just basically better in every way than a traditional stepper motor. Well, better in every way except cost. But if you're working on an expensive, high-quality, high-speed 3D printer, then it's definitely worth considering something like this. Now, in 3D printing applications, often, the head will be accelerating back and forth, and that creates an opportunity to set up resonance in any structure that you build. And that'll cause wobbling and cause print artifacts. It'll probably cause print failures. It might even cause structural failures. But by perfectly counterbalancing it, I can completely eliminate that as an issue. Now, you might be thinking, well, that's good and all, but once you start laying down material, you're going to have greater mass on the output shaft. But I've thought of everything. Instead of having this mechanically coupled, this is passively counterbalanced. But what I can do on my large 3D printer is I can add a separate flywheel underneath the print surface that's spinning in the opposite direction. And what's more is I can calculate the weight of the load that I'm spinning, so the 3D printed object, and I can scale the acceleration of the lower flywheel so that it's perfectly canceling out that reaction moment, regardless of how big and heavy my prints are. So that's something that I'd really like to implement on future versions of the machine. But I have the printer in working order right now, and I'm actually going to be taking it to the East Coast RepRap Festival, also known as 3D Printopia. That's a gathering of the 3D printer people in Bel Air, Maryland. So if you're on the East Coast, I'd highly recommend dropping by and checking it out. You can see my printer, you can see all sorts of other stuff from other members of the community, and all the latest and greatest stuff should be there. So if you're shopping for a 3D printer, you actually get to see the thing hands-on, and maybe you could think about, do I want to buy one of those or not? So it's a really cool opportunity to meet and network with people in the 3D printing community, see all sorts of cool stuff, and you can check out my large form factor 3D printer with 4 print heads. Today, I'm not in my usual space. I'm actually at the Louisville Level 1 Hackerspace. Let me just take you on a brief virtual tour. So over here, we've got a full wood shop with a gigantic router table. If you've ever worked in a metal shop, these machines should be very familiar to you. You can make basically anything out of metal using a machine like this. There's all sorts of great stuff here. We've got a welding station back here so you can weld stuff if you want. I'm set up over here, working on this little workbench. We've got some 3D printers here. We got resin printers, some old bed slingers. We have the illustrious, got a floating couch. We've also got a laser cutter, got all sorts of art on the wall. This gigantic waterfall of crimped connectors. This is just like a dream come true for anyone who really likes to build stuff. Membership here is $50 a month, and you can come in and use all of these tools. So big thanks to this Louisville Hackerspace for existing. I think it's really awesome, and if I had one of these in the areas that I lived, I'd definitely want to become a member of them. You can build just about anything with the tools that you have available at a space like this, but the one thing you probably couldn't build is a website. But don't worry, today's sponsor has you covered. With Squarespace, you can create and build your own website in a matter of minutes. Just log in with your Google account and start putting a website together. It's really convenient, and they have a bunch of cool features to help you get started. You can even sell things through Squarespace with their e-commerce tool. So let's say you had some cool art project and you wanted to sell it online. You could do that through Squarespace. Also, they have a bunch of AI-driven tools that will help you write your articles or add copy for the things that you want to sell there. I've been using Squarespace since before they sponsored this channel, so it's just a product that I really like and believe in. So if you're ready to get started and build your own website, head to squarespace.com and start your free trial today. And if you like what you see and want to launch your own website, go to squarespace.com/NathanBuildsRobots and get 10% off your first website or domain purchase. Sorry for my confusing mess of wiring down here. I've just hooked this up to a power supply and a signal generator. So this power supply is going to be providing the voltage to run this thing, and this signal generator is just producing a square wave that's sending steps to this stepper driver. If you're at all familiar with how to wire up a stepper and stepper driver, this should be very familiar to you. This normally isn't something you'd have to deal with. I've just been kind of hacking things together with all the random connectors and supplies that I've been finding around the hackerspace. So doing it in true hacker fashion. One of the advantages that you have with a servo motor like this is it's not wasting a bunch of current when it's at standstill. It knows that, hey, I'm not experiencing a lot of load or resistance here, so it just scales down the amount of power that gets delivered to the motor. And when I try to push back against it, it'll automatically scale up the current to resist that motion. Another advantage you get with a stepper motor like this is, aside from the speed, acceleration, torque, and lower power consumption, is that you can go very slow and precise. One issue that you have with stepper motors that I was really running into as an issue on the first version of my Polar printer is that they don't have the best resolution. However, this one, since it's closed loop controlled with a high precision encoder, you can get really precise movements out of this. This has a 10,024 position encoder, and I have a 10-to-1 gear reduction here. Once I've run it through a 10-to-1 gear reduction, this will have over 10,000 positions in terms of its resolution. So it'll be very precise, and it'll get rid of any ringing artifacts that I'll have. You may know with regular stepper motors, they tend to cog. So like as you turn it, you can feel like it's almost like there's little bumps inside of the motor. With this one, it's a lot smoother because it's just constructed differently to produce more clean motion. This is just me turning down the speed so you can see how slow and precise I can get the motion here. So we're going to go down by factors of 10. I don't know if this is the top speed of the motor. I think I could probably go faster if I fed this some more voltage or improved the signal lines or something. But I can slow it down. This is a factor of 10 slower. This is another factor of 10 slower. This is another factor of 10 slower. And another factor of 10 slower. I know you can't even see this moving anymore, but it's moving. And here's even another factor of 10 slower beyond that. So just the granularity of control that you can get on this thing, I mean, you can see this is moving 5 steps per second, but it's completely imperceptible to me how fast this is moving. I could set up a time lapse to prove it, but you just got to trust me here. This thing is moving. It's just moving extremely precisely and slowly, so you can't really see it. And there's not really any cogging to speak of, even when running at these lower speeds. It's just a really ideal setup for any type of 3D printing application. So yeah, these are just really cool motors. I'll leave some links in the description where you can pick some of these up. I'm using a NEMA 23 sized one here, but they also sell them in NEMA 17 sized, so the smaller ones that are more typically used in 3D printers. And those ones are equally fast and powerful. I mean, this one's probably more powerful because it's bigger. They just run super silently. You can't hear these at all when they're running like this. And I've seen a couple 3D printers set up with these A30P motors. They seem to work really well. The next version of my polar printer is going to be absolutely bonkers. If you aren't subscribed already, make sure to subscribe so you can see what this looks like when it's in a final application. And I'm really wanting to do some more experiments with the counterbalancing and getting those high rotations with zero shaking of the frame. It's going to be really cool stuff, so yeah, make sure you subscribe so you don't miss it. And again, if you want to see my large 3D printer, the Quadrupolar Express, as I like to call it, in person, make sure to check out East Coast RepRap Festival if you're going to Bel Air, Maryland, or live in the surrounding area. I think that one has like an entry fee, but it's very reasonable, and I'll flash it up on the screen here if I can figure that out. So thanks again for watching, everyone. Let me know what you think I should do with this crazy motor and the counterbalancing setup if that's something that all interests you. All right, that's all. Thanks for watching, and I'll see you in the next episode.